Hi class, here we are to talk about the different types of solutions. We're going to talk about unsaturated solutions, saturated solutions, and then supersaturated solutions. As we work through these definitions, let's use sodium chloride as an example. So sodium chloride has a solubility of 36 grams in 100 grams of water. So if I took 36 grams of that solid sodium chloride and I put it into 100 grams, which is 100 milliliters of water, since the density of water is 1 gram per milliliter, the mass and the volume are similar here. So if I took 36 grams, it would completely dissolve in 100 grams of water. But let's say that I took 20 grams of NaCl in 100 grams of water. This would be completely soluble because it's less than the maximum amount of solid that dissolves, so this is termed an unsaturated solution. And an unsaturated solution is a solution where there is less dissolved than is possible. So less than the maximum amount of solute is dissolved in that unsaturated solution. This is pretty common. You'll get complete dissolution here, and you would observe in the bottom of your beaker there would be no solid at the bottom of that. So you put your solid in, it dissolves, and now you have a homogeneous mixture. Now let's say that we put 40 grams of sodium chloride in 100 grams of water. This would not all be soluble, and so we will have reached our solubility limit, and this is a saturated solution. So saturated solution is one that contains the maximum amount of solute that can be dissolved, and often solid will remain on the bottom of that flask. So if we have a container and I put the 40 grams in, 36 would completely dissolve, but there would be 4 grams of solid remaining on the bottom of my beaker. Now let's say that we take this 40 gram saturated solution and we heat it up. If we heat it up, the solubility will increase with increasing temperatures. So if we heat it up enough, all of this will completely dissolve because the solubility increases as temperature increases. So now we have a unsaturated solution once it completely dissolves. And if we have this unsaturated solution and we cool it carefully below now room temperature, or to room temperature back to where it started, where that 40 grams initially was insoluble and it was deemed a saturated solution. But if we cool it carefully, we can avoid the crystallization process. And so those ions will remain dissolved in solution, and we have a super saturated solution. And this is where there is more dissolved than is possible according to the solubility limits. So just how can we form this supersaturated solution? Well, these molecules or ions, in order to form the solid again, must crystallize in a very ordered, organized way. And that takes time. So this crystallization process can be especially slow. So if we're careful to keep the solution stabilized, we can minimize the crystallization process. And quite often these supersaturated solutions are unstable and will quickly crystallize with a little bit of perturbation or like a seed crystal to help get things started. So honey and syrup are common examples of supersaturated solutions of sugar that sometimes you'll see your honey crystallize in your cabinet if you leave it sit so long. The appearance of the supersaturated solution will look just like that of an unsaturated solution. So you would need to know more details about how the solution was prepared if you were just looking at a picture or a beaker full of a solution. They would both be homogeneous mixtures of that material. As I mentioned before, solubility generally increases with increasing temperature. And for ionic solids, we have a plot of curves corresponding to the relationship of temperature and solubility. Now, at first glance, this plot looks exceedingly complicated, but I'm going to walk you through how to read this type of plot. First, let's look at the general trend that we see here. Most all of these curves increase from left to right, so their curve goes up. And these curves correspond to the increasing solubility with increasing temperature. So if we look at the y-axis, it's the solubility of the salt in 100 grams of water, and the x-axis is temperature. So as temperature increases, the solubility increases. Okay? Now, there are exceptions to that, right? There's these cadmium and cesium salts that have actually decreasing solubility with increasing temperature, and those curves go down from left to right. So just be aware that there are exceptions, but if you're asked a question and you have the plot available, which is totally possible, you should be able to read the information from the plot. Let's say that I want to prepare a solution, an unsaturated solution of potassium chlorate, KClO3. Can you find that curve on the plot? If I want to prepare an unsaturated solution of this at room temperature, which is 25 degrees Celsius, I can read this chart to find the solubility limit at that temperature. So reading the x-axis at 25 degrees Celsius, I find that the maximum amount that is soluble is just under 10 grams of potassium chlorate. Let's call it 9 grams. Let's say the solubility limit is 9 grams in 100 grams of water. So if we're on this curve, that mass is going to be completely soluble. Anything above that curve will not dissolve. Okay, so an unsaturated solution of potassium chlorate would result when I dissolve anything less than 9 grams in 100 grams of water. If I wanted to dissolve it in 200 grams of water, I would just double that. So anything less than 18 grams would still be an unsaturated solution. Now let's think about putting 20 grams into 100 milliliters. If I put 20 grams into 100 milliliters, that's going to be a saturated solution. 9 grams are going to dissolve, and 11 grams, what's in excess of that solubility limit, will be sitting as a solid on the bottom of that container, where the crystallization and dissolution process are in equilibrium with one another. But what if I wanted to take that solution with 20 grams of solid and make it supersaturated? How would I do that? Well, I would have to heat it up in order for the solubility to increase and dissolve all of that solid material. So I need to increase the temperature enough to completely dissolve that. So according to my plot, I would need to heat up my solution in excess of about 50 degrees, maybe 55 degrees, okay, to become now unsaturated, because now we're below the curve. So anything below the curve at that temperature would result in an unsaturated solution. So then we'd have to cool that back down very carefully, and if we don't get any precipitation out, we would have a now supersaturated solution. So we can get all that kind of information about solubility and whether or not we have a saturated versus an unsaturated or supersaturated solution based on information of how it was prepared and where we are and with respect to that curve. So if we're below the curve, we are unsaturated, no matter what. If we are above the curve, we are either saturated or supersaturated, depending on how the solution was made and the appearance that we see. Let's give you a chance to interpret this plot by answering this question. So if 45 grams are dissolved in 100 grams of water, we are at this point on my graph. And here we are on that solubility curve, so we are on or below, it is deemed an unsaturated solution. Once it is cooled down to 30 degrees Celsius, as long as no precipitate is observed, we have now a supersaturated solution. Okay? So Keep in mind how to read these plots. There are some problems in the homework and other on practice exams for you to work through. But please let me know if you have any questions. Thank you for watching.